Section 2.1 is on observing the sky. The top of the sky is called the zenith. 90 degrees from the zenith is the horizon. That's where the sky meets the ground. Now, what you see in the sky depends on where you are on Earth, what time of day or night it is, and what time of year it is. Let's say you go out at midnight on a clear night and see a bright star close to the zenith. That star will not be at the zenith anywhere else on Earth. On this figure, Earth is rotated such that North America is on top. If it's midnight for us, it'll be early morning in West Africa, say Morocco. If it's still dark out over there, a different star will be at the zenith for an observer there. Even for us, this star won't remain in the zenith for long because the Earth keeps turning. 1 hour later, it would have moved a little bit in the sky. The stars all appear to pivot around the celestial poles. So in our sky, we get to see the North Celestial Pole. If you lived in Australia or South Africa or Argentina, the South Celestial Pole will be somewhere up in the sky. The North Celestial Pole will be below the horizon. The North Celestial Pole is the projection of the North Pole onto the sky. It's not a physical thing, it's just a direction in the sky. The stars appear to lie on a spinning sphere, which we call the celestial sphere. The projection of the Earth's equator onto the sky is called the celestial equator. There happens to be a bright star close to the North Celestial Pole, aptly named Polaris, or the North Star. It stays in the same part of the sky all the time. So it's extremely useful for navigation. All the other stars pivot around it. There's no bright star near the South Celestial Pole, so navigating is a little trickier. Here is a time-lapse image of southern stars. Each star appears as an arc because it's moved during this long exposure photograph. Can you guess roughly what the exposure time was? If you like, you can pause the video and think about it. Okay, here's my guess. Each star would go all the way around in one day, technically once every 23 hours, 56 minutes. So a semicircle would be around 12 hours. A quarter circle would be around 6 hours. Each of these arcs is way shorter than that. I'd say the exposure time was a bit less than 2 hours. Chicago's latitude is 42 degrees north, so Polaris is 42 degrees above our northern horizon. The image at the right shows how stars appear to move in our sky at mid-latitudes. Stars that are close to the North Celestial Pole never rise or set. They just go round and round. They're called circumpolar stars. Those that are further away rise somewhere in the east and set somewhere in the west. If we travel to the North Pole, as shown on the left over here, we'd see Polaris at the zenith. All the stars you can see would then be circumpolar. You'd only see the stars that are north of the celestial equator, but you'd see them year-round. Well, you'd see them for the 6 months that you have night. For the other 6 months, you'd have day, and so you won't be able to see stars at all. 24 hours a day, the sun would be up. So there are no stars that rise or set if you're at the North Pole or at the South Pole. All the stars are circumpolar. They just go round and round. At the equator, Polaris would be on the horizon, and all the stars you can see would rise and set, and there would be no circumpolar stars. That's shown in the middle. In every part of the world, people have connected stars together to form imaginary patterns called constellations. Different societies have come up with different constellations. Modern astronomers have adopted constellations from ancient Greeks, many of which go back much further to ancient Babylonia. Here's the constellation Orion. It's one of the easiest constellations to spot in our winter sky. Like every other constellation, it's not a physical thing. The stars in a constellation have nothing in common except that they happen to lie in the same direction as seen from Earth. The three stars that form Orion's belt may seem similar. They look roughly equally bright, they're all blue, but they actually have nothing in common. They're not close together in space. The star in the middle is actually way further from us than the other two. If you flew to a different part of the galaxy and looked at these stars, they'd form a completely different pattern. They wouldn't look like Orion anymore. We see different constellations at different times of the year because the Earth orbits the Sun. At night, we're facing the stars that lie in the opposite direction as the Sun. So the stars we see in August are on the opposite side of the sky, out in space, as those we see in February. Whatever constellation lies behind the Sun, you definitely won't see. So in August, you won't see Cancer because it's up in the daytime. That's a good time of the year to see Sagittarius. The apparent path of the Sun in the sky is called the ecliptic. There are 12 or 13 constellations on the ecliptic, depending on whether or not you choose to include Ophiuchus. Together, they're referred to as the zodiac, which means zoo because most of these are animals. Now we can include the ecliptic on the celestial sphere. On this figure, the ecliptic is horizontal. Due to the Earth's tilt, the Sun can be up to 23.5 degrees north or south of the celestial equator. It gets furthest north in late June. That's the summer solstice in the northern hemisphere. The ecliptic crosses the celestial equator on the 2 equinox days, and it's furthest south in late December, which is northern winter solstice.